This video briefly explains regression trees. There are two kinds of decision trees, and which kind to use depends on the nature of our dependent variable. We use classification tree when our dependent variable is either unordered, categorical, or both. We also use classification tree when our dependent variable is dichotomous or binary. We use regression tree when our dependent variable is continuous or can be ordered in any manner. Regression tree is another example of a supervised approach to data collection. And why is that so? This is a supervised approach to collect data because we predetermine the independent and dependent variables beforehand. And these are the list of independent variables I intend to use in my study. Regression tree is another example of a supervised approach to classify data because we predefine the dependent variable. In this case, I use the total cognition score as my dependent variable. This is an index based on 3 elements. The first element consists of the scores for immediate and delayed word recall. The second element consists of the scores for working memory. The third element consists of scores for mental status. And when we add up these 3 elements, it ranges from 0 to 35, with higher scores representing better cognitive performance. So, how is the regression tree differs from the ordinary least square regression? In the ordinary least square regression, the same formula applies to all observations in a given dataset. However, sometimes certain characteristics, certain attributes in a given dataset, they can interact in complex and non-linear ways. When that's the case, we can use regression trees to subdivide the data into smaller segments. This is what we mean by recursive partitioning. After we subdivide the data into smaller segments, we feed a model to each segment of the data. And here are the main components of a regression tree. The main components of a regression tree are the same as the main components of a classification tree. A regression tree is a tree-like graph. And it is a tree-based method using a top-down approach to make predictions. And here are the different subsegments of the dataset, and a model is fed into the different subsegments of the same dataset. And there are 3 components to a regression tree. We have a root node. The root node is always the independent variable with the highest correlation with the dependent variable. The root node is further branched into one or more internal nodes. And from each internal nodes, we can further subdivide into one or more leaf or terminal nodes. So in this example, college education occupies the root node. Having a college degree or not is the independent variable with the highest correlation with total cognition score. Put it in a different way, college education is the most important variable associated with total cognition score. And there was 10,250 respondents in this analysis. And everything adds up to 100 when we subdivide our data set into different segments. So, from the root node, we further partition our data into several internal nodes. On the left side of the root node, we have those without a college degree. About 79% of our respondents do not have college degrees. And if you look at the right side of the root node, they consist of those with college education. About 21% of our respondents have college education. As you can see from here, the predicted total cognition score is lower for those without a college education. It is 20 for those without a college degree, but it is 24 for those with at least a college education. And among those without a college education, this internal node is further subdivided into two more internal nodes. On the left side of this internal node, we have the non-whites. About 22% of the respondents are non-whites with no college education. On the right side of this internal node, we have white respondents with no college degrees. As you can see from here, they are 57% of respondents who are whites who does not have a college degree. And as you can see from here, the predicted total cognition score is somewhat lower among non-whites without a college education. It is 18 here and it is 21 for whites without a college education. So, as you can see from here, whites without a college education is still doing better in terms of cognitive performance compared to non-whites without a college education. And from these internal nodes for whites without a college education, these internal nodes for whites with no college degree, it is further branched out into those with the length of stroke of at least 1 year and those with the length of stroke less than 1 year, and about 7% of our white respondents with no college education experience stroke for at least a year, and about 49% of the white respondents with no college degree experience stroke for less than a year. And as you can see from here, the predicted total cognition score for those with stroke for more than a year is somewhat lower than those with stroke for less than a year.